I'm Anil Kumar, and here is solution of question number 28, part C. For each function, sketch the graph of y equals to f of x and find an expression for f dash x. Indicate any point at which f dash x does not exist. In previous two videos, we have already answered part A and B. You know the strategy. I'd like you to pause the video, answer the question, and then look into my suggestion. So in the first part, we will sketch the graph of the given function, which is f of x equals to absolute value of absolute x minus 1. So let's sketch this graph first. So when I say absolute x minus 1, then it means that the graph should be, absolute function is kind of like this, and when you take away 1 from it, it moves 1 unit down. So the absolute function will be kind of like this, right? So let me sketch this part. Well, so this is the inside part of the function, correct? Now when I say, so this part which I have sketched is absolute x minus 1. It is not f of x. But when you sketch f of x, then what happens? The negative part flips and becomes positive, right? So you get this kind of a graph. Is it okay? Moving up like this. So that is the graph which you now get, right? So this is the function which I'm writing f of x as all this. Is it okay? So f of x is always positive and look like this, where the maximum, the local maximum is at 1, and these points are, if I write x as 1, you get a 0 or minus 1, right? So that is how the function is. Now, if that is your function, can you tell me or sketch the derivative of this function? It's not very difficult. As you can see, slope of this line is positive from 1, and at 1 and minus 1 we have corners, so it does not exist, right? So it does not exist here, does not exist here. It will not exist at this point also, right? That is also a corner. So let me start with the last part, which is f dash x does not exist at x equals to minus 1, 0 and plus 1. That is my first thing. Now, how much is the value of this function at other points? So you can see from the graph that the value of the function here is negative 1, right? So from minus infinity to minus 1, it is negative 1. So we could say it is negative 1 all along. So if this is, let me say this is negative 1. So let me go a line like this, and this is negative 1, kind of like this. Do you see that? Negative 1. Here is positive 1. So from this place we have positive 1 to this place. Is that okay? Thereafter it becomes again negative 1. So it will be negative 1 like this. And then from here it becomes positive 1. So from here it is positive 1. Correct? So that is how the graph should be of the derivative. So this is negative 1 for us, and the graph of f dash x is drawn in blue ink. Correct? Now what I left was the equation for your function and its derivative. Correct? I'd like you to pause the video and at least write down the equation. Here is how we'll write down the equation for f of x. It is a piecewise function, as you can very clearly see. How many pieces? 1, 2, 3, 4. Correct? So the first piece here is same as x minus 1, correct? But same as x. The first piece is same as x minus 1. So basically this function gets split into 4 different functions. So it is x minus 1, or it is minus of x plus 1, or it is plus x plus 1, correct? So those are the different equations which you get from this function. So in this interval, the slope is negative and it has moved 1 unit to the left. So 1 unit to the left, or you could say, well, from the interval minus infinity, so let me write from minus infinity to minus 1, the function is same as x minus 1, right? Same as x minus 1. You see it's the same graph. Do you see that? The graph which we had drawn earlier. The second half, we see that the equation, it has a y-intercept at 1, right, and slope of 1. So we could write this as x plus 1. So x plus 1 between the interval from minus 1 to plus 0, okay, to 0. Now, we could include these points in this particular interval, so let me write this. We could include this point, okay. Now, this half is negative slope, but the y-intercept is 1, so we could write this as negative x and plus 1. So I included 0 in that one, so we'll not include 0 here, but we'll include 1 on this side, okay, so we'll include 1 on this side. And the last part is same as x minus 1, when x is from 1 to infinity. So that is how you could write the absolute function split into these four. Well, so it's up to you. You could include 1 and minus 1 in these functions also, correct? As far as the derivative of this function goes, so in these intervals, what is derivative of the function? So we could have four derivatives. Here it is plus 1. Here again it is plus 1. Here we have minus 1, right? And in this part it is plus 1. I did a mistake here. The first part will be minus x. The slope is minus here. So this is minus and this derivative is minus 1. Okay. So that is how the derivative is going to be in different intervals. So let me write this as from minus infinity to minus 1, minus 1 to 0, including zeros at this, 0 to 1, and from 1 to infinity, correct? So you can clearly see that the function is not differentiable at these corners. These values don't match up. Do you see that? They are different, minus and plus ones, right? So they don't match up. So at 3 points, the function is not differentiable. So at x equals to minus 1, 0, and 1, it is not differentiable. So that is how you could actually answer this question. I'd like you to, do a better job than what I have done here, but I was just trying to explain you the concept, and I hope that is clear. Thank you, and all the best.